Find the measure of WXZ, angle WXZ. Notice that. Find the measure of angle WXZ. Again, if you lost any room on the back of that page, just add another piece of paper to your notes. This is example 4. Find the measure of angle WXZ. By the way, as you're drawing this, notice this box here. Veteran students, what does box communicate?
Right angle.
Thank you. This is the universal symbol for right angle hood. This is the universal symbol for right angle hood. I just made up that word, sorry. Which means 90 degrees. So pay attention to that as you draw your figure here. I'll give you about a minute. Take your time, sort of. Find WXZ. Can someone please tell me how many degrees WXZ is? How many degrees is it? Did they give us that?
2x + 1 degree.
WXZ? Yeah, they did, huh? Right here. So we're done, right?
Yeah.
They asked me to find the measure. There it is. 2x + 1 degrees. Thank you, Mr. Rivera. Extra stamp. Maybe. Maybe. Why are we not done? Right. We want the degrees without a variable. So let's first figure out the variable, plug that puppy in there, and we'll figure out the degrees of the angle. Just like example 3, in other words, on your notes if you see it. The big angle equals to the two small angles. Right?
Yeah.
The big angle would be WXY will equal to this small angle plus this small angle added up. There's our equation that we'll use to solve for x. Watch. Watch this. The measure of angle WXY equals the measure of angle WXZ plus the other small angle, which would be ZXY. ZXY. There's your equation. All right, let's plug and chug. That picture right there. All right, here we go. WXY, let's see, WXY is 90 degrees. Is WXZ, let's see, WXZ 2x plus 1, nice. Plus 7x minus 10. Rocking and rolling. Nice. The rest is Math 1 stuff. Math 1, your teacher was supposed to teach you how to do multi-step equations. I'm not sure they did. If not, talk to me later and I'll give you some refresher course on that. I have videos that can get you caught up on how to solve for a variable. In other words, we got to get x alone on one side. Let's do it. Like terms? That's 9x is on. 2x's plus 7x is going to be 9x. Let's get the like terms together. Beautiful. And let's get the numbers together too, huh? 1 minus 10, help.
-9.
Rocking and rolling. Nice. We got the like terms together. Now let's proceed to get x alone. Let's get x by itself. Careful. What operation is that? That's subtraction. What's the opposite of subtraction? It's rock and roll and add. To both sides. Whatever you do to one side of the equation, you got to do both. I bring down the equal sign. Nice. Bye-bye to that. I got a 9x equaling 99. Sweet. Question so far? Good. Divide by 9. X is... Thank you. Let's not get all happy though because X is 11. Let's look at the mission. What was the mission? Let's see. Here's the mission. Find this angle. We found X is 11. That angle is 2x plus 1, right? So the measure of angle WXZ is going to equal to, here we go, 2x plus 1 degrees. I know what X is now though. So let me go and substitute it back in there, right? Right, so this is really 2 times X, which would be 2 times 11 plus 1. Exactly. 22 plus 1 would be 23 degrees. Mission accomplished. There's the angle measure, 23 degrees. Very nice. But logical, yeah? Would you admit that? It's logical. I mean, that's really the point of a lot of mathematics. You'll probably never see this in life unless you get into engineering or something, or construction. But your logical skills are actually sharpened. Your thinking skills, like a muscle. You do some curls, your biceps get bigger and bigger. The more curls you do, the more you're able to lift. The more mathematics you're able to do, the better thinking is done. The more capacity of thinking is realized in your mind, like a muscle. There's benefit to it, whether you're going to get into math or not. Let's see, that's example 4. Any questions before I go on to example 5? 2 more examples, we're done. All right, good. There we go. Yeah, there you go. Example 5, I'm going to copy that one down. We got a bigger angle here. I got 3 angles here. Here the mission is just find X. Cool. That means we could get happy one X by itself. Get all happy. So we got to form an equation. This angle right here has X in it. This angle right here has X in it. What about the big angle?
180.
Nice. The big angle is a 180 degree. It's a straight angle. In other words, from here all the way over here is half of revolution. Half rotation would be 180 degrees. We're ready to rock and roll. There's our equation. Again, the big angle equal to the 2 small angles inside of it. Let's do it. Here we go. I'm going to write out the equation. Write it with me. I'll put it in red this time for the Kansas City Chiefs. We're going to lose to the Rams. The measure of angle EGH, that's a big angle, equals to the, let's see, the small one would be, let's see, EGF. Look at, this is the EGF right here, the 2x minus 18. So the measure of angle EGF plus FGH. Rocking and rolling. I trust that's logical, right? The big one equals the 2 small ones. All right. Let's plug and chug, just like we did on example 5. Let's plug and chug. Rivera, what's the big one again?
Big one, 180.
Thank you. Look, I'm just replacing with 180. It's 180 degrees. Get it. Thank you. This one's 2x minus 18. And then 4x. We're rocking and rolling. You guys with me? Easy. The rest is math 1. Let's get x by itself. Math 1 time.
Okay. Sorry.
Right, 2x's and 4x's make 6x's. I got a minus 18 equaling a 180 here.
At 18.
Rocking and rolling. Let's add 18. Let's get x by itself. And we have 6x equaling, I want to say 198 if my coffee is kicked in, my afternoon coffee.
Yeah.
I'm really bad at mental math, but I trust that's it. Nice. X is, I have no clue. Nice. Was the mission to find X? Yes, we're done. We're done, huh? Exactly. Cool, cool. Questions? Okay, so the pattern in all these examples, the big angle equals to the ones inside it. That's it. That's always your equation. Before we get to our last example, yes? Yes, x is 33. Before we get to the last example, I want to go over one word, talk about this one weird word that's found only in geometry, mathematics, and then we'll do our last example. Here's a one word. So on your notes, put a little squiggly, like a little section, a section break, and write this word, big fat bold letters. Congruence. So on your notes, put a squiggly, like a line to divide the notes into a new section. Still the same notes, but I want to talk about this concept of congruence. And then go ahead and draw two angles here. Just like the way I did. Write the big word, the word congruence, because no one in here really knows what it means. You may think you do, but I'm pretty confident you don't. And I'll probably demonstrate it to you. I'll prove you don't right now. Or maybe some of you prove me wrong. That happens every once in a blue moon. The student will prove me wrong. So write the word congruence and then draw those two angles. So I drew one in Dodger blue and the other one in Kansas City Chiefs red. Let me name these puppies. I'll name this B for Bass, L for Lopez, M for Munoz. So I'm naming these after my period 4 students. I'll name this one C for Castillo. Put it red actually. I already have a B. V for Vargas. And I already have an M for, let's see, we got M. De Santiago. Huh? Go ahead. So I have angle BLM and angle CVD. No, this is just this is not example 6 yet. I want to talk about congruence only. So this is not officially an example. I just want to talk about this definition because none of you understand what it means. Even though you guys wrote it down last week on your vocabulary list, you don't know what it means. Trust. So I got to talk about it before we get into the last example. Now, watch this. Someone read out the definition of congruence from last week on their vocabulary list. I'll give you an extra stamp. First one to read it out loud. Just yell it out. What's the definition of congruence? Definition. Read it out loud. Go. Thank you. You got it. It's going to be okay, McMahon. It's going to be okay. So Esquivel gets extra stamp. One more time, nice and loud, Esquivel. Two angles that measure the same. Do these two angles measure the same here? Yeah, they're both 30 degrees. Exactly. Now, watch this. I'm gonna write a false statement. So go write false statement. I'm going to use a little logic in you, or on you. I want to see if who has some logical strengths here in this class. I'm going to write down a statement about these two angles, and whoever can tell me why it's false will get two extra steps. Now, let me warn you. The statement I'm about to write seems true. I mean, it's going to look obviously true, but it's actually false. And I want to see if someone can tell me why it's false. Watch this. So write this with me. Here's a false statement. Angle BLM equals angle CVD. Again, these are two angles I've named after some of my students. That seems true to me. BLM, that's 30 degrees. CVD, 30 degrees. But why is it false? Sure looks true to me. 2 stamps for someone can tell me why that's a false statement. Wait. I got you. One more time. So this is a false statement because the angles have different names?
Yeah.
Is that what you're saying? Okay. Good try. Why is this a false statement?
Because I know I want to see, but I don't want to see.
This is why we're in school, so we can learn to communicate.
What's the question again?
Why? Look at angle BLM right there, boom, in blue. Angle CVD, boom, in red. I'm saying they're equal. That seems true to me. 30 degrees, 30 degrees. I mean, but why is that false?
Because we needed it. Is it because they're facing the same way? Does that have to be PVC?
Hold on, one at a time. Go ahead, Gomez.
Does that have to be PVC facing the opposite way?
No, that's just, remember naming it. As long as it's in the middle letter, you're good to go. Thank you, though. I saw another hand. McNair, you want to add something? Hit it. Did I see another hand over there? 2 stamps. Why is this false?
You stated it was false.
Hold on. Go ahead, Gomez. Huh? That's a deep conversation. Huh? Esquivel, go ahead. Okay. I like. So you getting the approximate. I like that. That's not it, but I like that how you're thinking. No. I'll give you a hint, but if I give you the hint, it's going to drop down to 1 stamp extra instead of 2.
Fine.
Okay, or no?
Stamp is a stamp. Go. Stamp is a stamp.
All right. What if I said this? This is a hint. Castillo, how old are you?
17.
Who else is 17 in here? Okay, so I'm going to use Munoz, Gomez, and Castillo. Castillo 17, Gomez is 17. What if I said this? What's wrong with that?
Yeah, different.
Different days, different months, so it might not be exact.
No.
They're 2 separate angles.
Castillo's an angle?
No, like they're 2 separate people, but
Yeah.
Okay. So here's. Wait, let me get it. Last name again, one more time.
Ross.
Are you talking about the angle?
Yeah.
Here.
But
So you're answering this question now. So why is this false?
because they're 2 separate angles.
Right. In other words, watch this. In English, watch this. In English, what happened? Okay. You've been seeing this little equal sign since you've been like a little mocoso since like childhood. But because you've been seeing it so much, you guys tend to forget how powerful a symbol that is. In English, that actually means this. Now read it to yourself. That's false, huh? Castillo is in a red sweater. He's a different human being than Gomez. This statement says they're the same human being. They're the same person. They're not the same person. The only thing that they share, welcome, coming in. The only thing that they share is the age. So back to the angles.
Oh, they only share the 30
Right. Angle BLM is one angle in reality to the left, floating in space. The red angle CVD is another angle. They're two separate angles. This statement is saying, look, angle BLM is angle CVD. No, that's false. But what we can say is this. Here's what we can say. So,
Equal the same.
you get the 2. Well, no, I gave you the hint. You get the 1. Watch this. Here's what we can say. Put true statement now. Watch this. What I can say is angle BLM is congruent. Look at the congruent symbol. To angle CVD. It's an equal sign with a little tilde symbol over the equal sign. All that means is what Esquivel read about 5 minutes ago. That they have the same measure, namely 30 degrees. That's all they share is the measure. They're two different angles, but they share the same size. That's all it's the same. Can't say that. It's philosophically erroneous, but we can say this. Here's our last example now. Questions so far? Last example and we're done. Example 6. I'm going to write this down. But here you're going to write a statement. Part of the directions. Ray BD bisects angle angle ABC. Solve for X. So I'll give you about a minute to copy that down. Last example. So ray BD, the ray BD begins at B and goes on forever. And I'm saying, look, it bisects angle ABC. ABC is the big angle. From here, let's see, ABC, that's from here all the way over here. I'm saying that ray bisects it. What does bisect mean from the vocab? Extra stamp. Someone just blurted it out. I think it's angle bisector or bisect.
It's angle bisector.
Read it to me, Lopez. Hit it.
A ray that divides an angle into two angles that are congruent.
So a ray that divides an angle into two smaller angles that are congruent. We just went over what congruent is. They're the same measure. That means this red ray that I highlighted chops right in half angle ABC, which means this angle and this angle are now the same size. Assuming it's 90 degrees.
Yeah, assuming.
There's no symbol that says it looks like 90 degrees, but we can't assume. But I like how you're thinking. They have to be the same size, in other words, is what you're getting at. Angle ABD, this small angle, and the angle DBC have to be the same because the ray chops in half the big angle. So there's my equation. This small angle equals the other small angle because the ray bisects it. So here we go. Here we go. So, because the ray BD bisects a big angle, I can say the measure of angle ABD equals the measure of angle DBC. Notice, because I put the little m in front of the angles, I can say they're equal because I'm talking about the measures, not the angles themselves. So it's not a false statement to say this. The measure of this angle is the measure of that angle. Not the angles, but the measures of it. See, it gets philosophical. Let's plug and chug. 6x plus 14 is 3x plus 29. I would recommend and encourage you guys to start replacing the word equal with the word is. It's more logically sound. is, 6x plus 14 is 3x plus 29. Since it is that, we can start getting x by itself now. So far the equations I've been throwing at you, the variables on both sides. How the heck are we going to get the variables on one side? That's the question. That's math 1 stuff. Help. I appreciate that. Thank you. How the heck are we going to do that? What do we do to both sides to get x's on one side? Because if I'm going to get x alone, I got to get it on one side, right? Before I get it alone. Think of math 1 days.
Put it on the other side.
Thank you. How though? I got to do something to both sides logically.
Try 3.
Just 3?
3x.
Thank you. From both sides. Look at it. Whatever I do to one side logically, I got to do the other. And this is going to end up eliminating the variables on one side and bring it to the left. Then we're in business, because at that point we can start getting x by itself. I got 29 on the right. Let's see. 6x's minus 3x's become 3x's. I got the plus 14. We're rocking and rolling. Rocking and rolling. Let's get rid of the 14. Let's subtract 14 from both sides. Bye-bye to this. I got 3x equaling, I have no clue. 15 sounds good to me. And then let's divide by 3. X is 5. What was the mission?
All right.
We're happy. We're done. Mission accomplished.